explore more of AI in agriculture. So very briefly, I would like to introduce Dr. Manoj sir. So he is an experienced industry expert with over 30 years of experience, and so he is known for bridging the gap between industry and academia. He has deep competencies in preparing industry-ready professionals. So as per the qualification is concerned, he is a PhD in computer science from Thapar University, and he has completed his MTech in signal processing from Netaji Subhas Institute of Technology, that is under University of Delhi. He has worked extensively for Industry 4.0 technologies, and he has also built a lot of IT applications for Fortune 500 companies. And he is engaged in the digital transformation of global companies like General Electric and Infosys. So his primary technical expertise includes artificial intelligence, machine learning, big data technologies, and cloud computing. He has also been a Microsoft certified trainer with globally recognized certifications from Amazon Web Services, IBM, and Microsoft. So currently, sir is working as the founder and CEO of Mystic Minds Private Limited, which is a company which helps students to meet their career expectations. And in his current role, he is also assisting students outside the computer science discipline and those studying agriculture, pharmacy, agribusiness management, and so on, so that they can get proficiency in artificial intelligence. So within this assignment, the students develops different AI solutions tailored to their domain. So this was in brief introduction of Manoj sir. So I'm very thankful to him for devoting his time for this workshop today. So I'll not take much time. On behalf of my university, on behalf of my principal, and on behalf of my dean, I would like to thank sir for taking his time for us. So, sir, we have UG students, PG students who are in MSc and PhD course in our university in different disciplines, and also we have faculty members from our university who has joined today's program. So they have great expectations regarding artificial intelligence, how we can cater more to it, and uh, im- how we can derive more benefits out of it. So the stage is yours, sir, now. So you can please start. Thank you.
So many thanks, Sinha sir, for introducing me to the audience. And I'm really thrilled to be here sharing my knowledge in the field of artificial intelligence and particularly aligned with agriculture. So that will be the session direction altogether. Very briefly, that's what Sinha Saab has already shared, that I have worked across the industries, across the domains. I have worked with Infosys, General Electric, Goodyear, ECE for more than 25 years. And then last 5 years I have devoted to academia also. My last assignment was with Chitkara University as Pro Vice Chancellor. And now I have, after 30 years, I have started my own company, Mystic Minds. So that is where I'm trying to contribute as far as gap between career aspirations of students are concerned and their competencies are concerned. So when we talk with the students, so they do have certain career aspirations and they do have certain competencies. So we at Mystic Mind are particularly working on bridging that particular gap so that students get to their career aspirations by improving their competencies. So that is the motive. Next 60 minutes, our focus will be to explore AI in agriculture from 30,000 feet view. Now, many of you might be having a clear idea about 30,000 feet view, but let me very quickly run through what is 30,000 feet. So this is what it is: 30,000 feet view, where you can see very broadly the earth from a very large distance. When you move to 10,000, it is primarily we are cruising towards the earth. Then it is 1,000 feet, then it is 300 feet, then it is 3 feet, and then it is 1 feet, where you will be able to see the minutest details of the subject.
Uh, sir, sorry to interrupt. Your slides are not
Is
moving,
it?
sir. Uh, yeah, so can you please put on the slideshow mode and
Okay, okay,
slideshow
okay.
mode?
Let me do that, sir. Let me do that.
Yes,
Let
yes,
me do one thing. Let me share my whole screen.
yes,
Then it will be perfectly okay.
yes.
So now, sir, slide is visible, sir.
Sir, slide is visible, but it is not moving, sir. Yeah, yeah, it has started moving. Yes, sir.
Okay, okay,
Perfect.
perfect, perfect, perfect. So
Yes, thank you.
we are currently during next 60 minutes we are trying to get a view of artificial intelligence in agriculture from 30,000 feet view. What is 30,000 feet view? It is primarily a view from a very far off place. Just like you are seeing on your screen that I'm trying to capture my earth from a 30,000 feet view. Slowly we'll move to 10,000 feet, then 1,000 feet. I would request everybody to put yourself on mute, please. Then,
Please mute yourself, everyone.
yeah,
Please mute yourself. Dharamsila, I can see on the screen. Dharamsila, you're requested to please mute yourself. Yeah, and please don't turn it on.
then it is 300 feet, then it is 3 feet, and then it is 1 feet. So that will be the journey of artificial intelligence into the domain of agriculture, starting from 30,000 feet to 1 feet. Today, next 60 minutes, we are trying to devote ourselves to 30,000 feet view. So you will get a clear view, clear idea what is in store for you if you drill down to this particular domain altogether. I hope I'm making the expectation very clear. So that you get all the blocks that yes, these are the blocks you need to work on so that you are an expert in the field of artificial intelligence when it comes to implementing it in the domain of agriculture. So let's gear it up. So 30,000 feet agenda will talk about artificial intelligence. What is AI in agriculture? If a particular use case will implement today so that you will get a feel of it that yes, that is how things will move when you start exploring the concepts. And what are the future jobs available in agriculture when it comes to 21st century? So when it comes to human beings, very lightly, when it comes to human beings, we do have IQ, that is intelligence quotient. We do have EQ, emotional quotient. We do have AQ, adversity quotient. And when it comes to morality, we do have MQ, that is moral quotient. This is what we human beings have. But what is artificial intelligence? If machine wants to imitate these behaviors, these quotients like IQ, EQ, AQ, MQ, then it is said that machine is artificially intelligent. That is the basic idea of it. So just think over a scenario where a robo has intelligent quotient, emotion quotient, moral quotient, adversity quotient. Very, very dangerous. This is where we are heading towards. Beauty contests are being judged by robots. So very quickly, I'm sharing with you what is happening around us. Sports, we have already seen that robots are defeating human beings. Manufacturing, around 60 to 70% of manufacturing industry has moved to robotic manufacturing. Automated cars, self-driven cars, we have seen on roads. Tesla is there, Google is there, and all that. Construction, you might have seen in today's world that most of the things are automated. Healthcare, robotic surgeries are in place nowadays. Experts are sitting in the US and they are doing robotic surgeries here in India and vice versa. Our doctors are also doing the robotic surgeries of people sitting in the UK or Europe or America. Automation, there are large industries like refineries are there, steel plants are there. They are all automated. Banking, a lot of automation is happening. As soon as some fraud happens to your account, all of a sudden you get an SMS, you get an alert. So fraud detection is one of the major feature of artificial intelligence in banking sector. AR VR. Most of us do shop online nowadays, where augmented reality is there. So you are just sitting on in front of a screen and trying out various dresses, various attires. How this is where technology is seeping into our lives. Smart cities is the new concept happening around us, where each and every thing in the city is talking with each and everything. Like roads do have cameras, cameras will capture you and your violations. Similarly, electricity, similarly, administration, all the things are automated. Software development, chat GPT. Sinasar has very rightly pointed out that yes, this is what the disruption is. Most of the jobs are at stake, where things are getting repeated. That is where we need to just think what is happening around us. That will give us a clear picture that yes, this is where we need to work on. Agriculture tomorrow. You are the agriculture experts. You might be seeing that slowly and slowly, where most of the things were happening manually 5 years back, 10 years back. Now we are using technology. And when we are using technology, means there are certain benefits, there are certain pros and cons. So we need to look for those pros and cons, how to trade off those pros and cons into our favor so that we are 2 steps ahead of the technology. HR tomorrow. This is one thing you must be experiencing nowadays, that whenever you apply for a job, your profile, your resume, your CV, your biodata is not read by a person. It is read by a robot, a machine, an algorithm, where it will find out whether your profile is matching with the job description, and then you are taken to the next stage. So a lot of things are happening in the background. Teachers tomorrow. Today, I'm presenting this particular topic in front of you virtually. After COVID, we have closely seen that teachers have moved from a personal appearance to a virtual appearance. And now, in coming time, you will see that you won't see anything in front of you, but a robot will be teaching you. That is a future, and it is happening around us. So we need to pull our socks, because robots are going to take our jobs. If we do not, if we do not realign ourselves with the technology, if we do not upskill and reskill ourselves, if we do not move towards the technologies which are happening around us, will be wiped out. So it is very, very important for us to answer this question. Are we ready for the future? Or next question, are we future ready? So let me spend a minute on this. There are 2 lines. Are you ready for the future? And second is, are you future ready? Question will be, are these things synonyms? Answer is no. These 2 lines are not synonyms, but there is a very fine difference between 2 lines. When you are talking about ready for the future, basically you are talking towards the challenges. And to face those challenges, to overcome those challenges, you need to upskill yourself. That is where you need to be future ready. That is where we are going to spend few minutes on this, because if we align ourselves with AI as quickly as possible in this particular arena happening around us, I think we'll win this particular battle altogether. So this is first suggestion from my side: align with AI as quickly as possible in your domain area. But what is AI? Let us talk. Let us spend a few minutes on what is AI. It was a term coined by Stanford professor John McCaffrey in 1955. He defined it as a science and engineering of making intelligent machines. A little bit clumsy. Let us drill down to the basic definition. There are 2 words, 2 alphabets, A and I. Let us first talk about A. A is artificial. What is artificial? Which is not natural, which is synthetic, which is made by human beings. So this is the general definition. So if I read out, artificial is used to describe things that are made or manufactured as opposed to occurring naturally. Artificial is often used as the opposite of natural. A close synonym of artificial is synthetic. That is where we need to understand that artificial is what made by humans, produced by humans. It is not occurring naturally. So this is A in AI. What is I in AI? That is intelligence. What do you mean by intelligence? This is the capacity for abstraction, logic, understanding, self-awareness, learning, emotional knowledge, reasoning, planning, creativity, critical thinking, and problem solving. This is I, right? So just imagine if man-made machines have the capacity for abstraction, logic, understanding, self-awareness, learning, emotional knowledge, reasoning, planning, creativity, critical thinking, and problem solving. This is what AI is all about. So I'm trying to give you a very basic definition of AI so that you can correlate what we are talking about and what is in store for us if we want to enter into this particular world. I hope I'm making sense. I'll take all the questions toward the end of the session so that there will be a complete uniformity. I hope, Dr. Sinha, it is okay.
Yes, sir. I have already written in the chat box that the participants can can ask the questions in the chat box, and
Perfect.
you can answer it at the end of the session.
Perfect. 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 So now, when we are trying to open up the plethora of AI, artificial, man-made machines, intelligence means it can perform certain tasks which are human intelligence related. Because when you talk about abstraction, you talk about logic, you talk about understanding, you talk about self-awareness, you talk about creativity, you talk about critical thinking, problem solving. These things are human centric. We tell that yes, if I do have these characteristics, I'm intelligent. But when machine will have those things which typically human have, this is artificial intelligence. So if a machine can reason, if a machine can learn, if machine can act in such a way that would normally require human intelligence or that involves data whose scale exceeds where human can analyze, this is where AI will pitch in. So slowly and slowly, we are trying to make a picture of AI so that before moving into the field of AI in agriculture, we should have a basic knowledge of artificial intelligence. When we talk about AI, three types: narrow, general, and super. When you talk about narrow, whatsoever is happening around you in today's world, whatsoever people are talking about, lot about artificial intelligence. They talk about Siri, they talk about Alexa, they talk about Google Assistant, they talk about a lot of help available through robos. This is all narrow intelligence, which is called weak AI. We talk about driverless cars. But if I tell Tesla, if driverless car can fly an aeroplane, answer is straightforward no, because that particular system is meant to handle a particular specific task, So that is where narrow intelligence. So whatsoever people are talking in today's world that yes, we do have AI systems, we have implemented AI and all that, that is narrow artificial intelligence. Journal. What is journal AI? Journal AI is when I took one example of driverless cars, when that particular system which is governing driverless cars can fly an aeroplane or can ride a bicycle, that is general intelligence. Means machines are so intelligent that they can switch their mind, they can switch their thought process. They have a self-aware consciousness to ability to solve problems, learn and plan for the future. That is where general intelligence is all about. And third is, so example. So example of general intelligence, one particular system is developed in the US, ROS intelligence. That is primarily one robo which can give legal advice to anybody and everybody by going through 1 million documents in a fraction of second. So that is where ROS intelligence is the first example of general intelligence. When machines will supersede humans. See the picture. So a robo is sitting on a lot of human beings. That is primarily super intelligence. So three types: narrow, which is happening around us; general, we are fast approaching; and super, in future. Example, I would request you to see one movie, 2001 Space Odyssey. You will see the example, fiction example of super intelligence in this particular movie. Whenever you get a chance, see this movie. So that is how things will move. Narrow intelligence, presently it is happening. General AI, it will take 10 to 20 years. Super intelligence, maybe 30, maybe 40. But yes, we are progressing towards this. So that is how things are moving. Very quickly, let me give you blocks of AI system. Pardon me for my fast pace, because I need to give you blocks. That is where I have written at the bottom my blocks of AI system. So after 60 minutes, we understand that yes, these are the things we need to explore to go to 20,000 feet, then 10,000 feet, then 100 feet, then 3 feet, then 1 feet. And slowly, I'll share with you the roadmap also for this. So first block is machine learning. Machine learning means when machine learns something. So this is the primary thing, primary step to implement AI. That is where it is saying it can be defined as a subset of AI. A lot of algorithms are there. You tell machine that yes, few pictures are there. Let me give you a very quick example. Few pictures are there. So this is dog, this is cat, this is dog, this is cat. You feed the machine, let us say 1,000 pictures, and then put 1,000 first picture in front of machine and ask the machine that yes, tell me what is this. So it will tell that yes, this is dog or cat, something like that. So that is where machine learning comes into picture. Types: supervised machine learning. So this example what I talked about, that yes, you give 1,000 examples to the machine that yes, this is dog, this is cat, this is dog, this is cat, this is dog, this is cat, and then 1,000 first picture you ask as a test case. So that is supervised learning. This is what we generally do in our education system also. 4 years, 5 years, our teachers teach us everything, and then they evaluate us on that particular thing. So we are learning under supervisor. So that is where supervised learning, supervised machine learning. Then comes unsupervised machine learning. Like, let us say you go to a junk place where a lot of junk things are dumped. So you need to see, you need to segregate. So you will take first block. First block is, let us say, electronic. So you will start collating electronic items in one. Then it is books, books in next block, next cluster. Third is, let us say, newspapers. Fourth is bicycles and all that. So you are trying to identify clusters. So that is unsupervised learning, that you do not know anything. First part, first supervised learning, we saw dog, cat, dog, cat, dog, cat. Somebody taught us. Now nobody is teaching us. We are just looking towards for clusters, associations, and other things in the data. Then reinforcement learning, Chandrayaan 3. So our Land Rover landed on Chandrama. In that particular scenario, nobody knew how to do that. So everybody was creating a hypothetical model around this. On Earth, they tested various models, and then hit and trial was done. In that particular scenario, we were succeeded. So that is in reinforcement learning. And semi is certain data is available, certain data is not available. So this is a broad of machine learning. Do not worry about various things. Do not worry about various strong terms and all that. At this moment of time, again, keep in mind that yes, you are on 30,000 feet at this moment of time. Slowly and slowly, we'll drill down. Next, deep learning. Deep learning is how our neural system works. A lot of researchers in this world are working on creating a copy, a replica of our brain, our neural system, neural network. That is where artificial neural networks are there. So various neurons are there, various layers are there, how you remember, how you recall, how you are angry, how you are emotional, and all that. So that's what our brain works. That is where, and our intention is to make a machine which can imitate those things, our emotions, our IQ, our EQ, our AQ, and our MQ. So that is where deep learning plays a very important role. It is again a subpart of machine learning. Data science, when you do have machine learning available, you do have deep learning available, and you do have a lot of data. And when you apply those things collectively in a system for a business problem, it is data science. So that is how, if we talk about AI in nutshell, AI is any technique which enables computer to mimic human behavior. A subset is machine learning. Subset is machine learning where statistical models are being used. Subset is deep learning where multi-layer neural networks are being implemented. And overlap is data science. So whenever somebody gives you these four terms, the purpose of touching upon this AI in nutshell is a lot of people talk about these terms as synonyms. They are not. There's a small difference between each and every term. So you need to know that yes, AI is the larger arena, the superset, then it is machine learning, subset is machine learning, subset is deep learning, and overlap is data science. That is how things move. So this is the brief introduction of what is AI. Uh, within a very short span of time, I'm trying to give you some information, some blocks, so that after 60 minutes you start exploring those terms. So my request to you will be just keep on writing those blocks. I'll share the deck also, so that afterwards you can go through this particular thing. That will be very beneficial for you if you start exploring those terms after 60 minutes. Benefits, that definitely yes, automation is there. It reduces human error. Repetitive tasks are eliminated, fast and accurate. It will not say that मैं अब थक गया. Machine will never say that I'm tired. Humans will say that. That is where it is saying infinite availability. And it will help us to accelerate our research and development. That is how benefits of AI are. Now, we know what is AI. Very brief overview, 30,000 overview. Now let us get a 30,000 overview of how to execute an AI project. Let us say now slowly and slowly I'm moving to the next step, that yes, okay, I understood what is AI. Now project kaise handle karna hai. So now let us look towards AI project life cycle. First step is you need to identify a problem. When it comes to agriculture, there are around 45 subjects defined by ICAR, main subjects. 45 subject means 45 problem domains. Now it is entirely up to you to identify a problem that yes, this is a problem which I can solve using AI. So that is the first step. Second is you have defined the problem that yes, this is the domain area I am going to work in agriculture, and then I need to collect the data. Data is most important because during the definition of artificial intelligence, we talked about, yes, this is dog, this is cat, this is dog, this is cat. I need to teach the machine in the form of data. So that is where the larger the data, the more accurate the system will be, because computer will know out of 1,000 pictures or out of 10,000 pictures or out of 1 lakh pictures. So data collection and preparation is the most important step. Then it is algorithm, AI algorithm. Either it is AI or machine learning or deep learning algorithm. We'll talk about this. At this moment of time, do not worry about these terms, right? Just try to understand the larger picture. So you take one algorithm, evaluate it, validate it, deploy it, integrate it, monitor it, maintain it. Then you look for ethical and legal considerations, because that is very important. Let me take one example of healthcare. Let us say I am a sugar patient or I am a BP patient. My data is with a hospital. So that is my personal data. So there are certain ethical considerations, there are certain legal considerations when you use data altogether. So this is very important step when you will be working on a AI project. You need to train the users, you need to evaluate the performance, and then you need to continuously improve. That is how the complete AI project lifecycle works. Again, I'm repeating, we are at 30,000 feet. So each and every block will have a separate discussion altogether. How to identify a problem, 2 days. Data collection, 5 days. Algorithm, 10 days. Evaluation, 2 days. Deployment, 5 days. Something like that. So that is how this whole life cycle will take a particular time. But yes, when you are talking about AI project life cycle for agriculture, first thing first, you need to go to the field where you need to identify a problem being faced by a farmer on ground. Then and only then you can do justice with the subject. Collect the data, because data is very important nowadays. During your 4 year or 4 year of degree, I'm talking about example of BSc agriculture only. You can move to MSc and PhD also. So when you are doing your UG program, you go to the field as assignments, right? You go to the farmers, you meet people. At this moment of time, just recall those events where you could have collected a lot of data, but you did not. Starting today, I would suggest very sincerely that whenever you go to a field visit, collect data, start collecting data. That is a gold mine altogether. When you are trying to work in the field of artificial intelligence, data is a gold mine for AI. Because we, again, example, pictures, 100 pictures, 1,000 pictures, 1 lakh pictures, lot of difference. Then again, you go for algorithm, you go for evaluation, you go for deployment, monitoring, ethical and legal, then adaptation and training of farmers, performance evaluation, and continuous. So that is how, when you are talking about agriculture and you are talking about implementing AI in agriculture, this is the process, this is the steps you need to follow. Each and every step will require various skills, which will drill down to when we'll move to 20,000 feet, 10,000 feet, 100 feet, 5 feet, 2 feet, 1 feet, and all that. So that is how we are going to move. So let us take one very quick real life example where AI is implemented in the field of agriculture. When you are interacting with a farmer, so broadly, 5 or 6 things. One is soil quality, water quality, seed quality, crop quality, environment, weather quality, and all that. And then environment. So these 3 things, 6 things work when it comes to farming, when it comes to agriculture. You are the experts. I'm a computer science person. But when broadly I talk with any farmer, he talks about मेरी मिट्टी की क्वालिटी कैसी है, पानी कैसा है, वेदर आज बारिश होगी या नहीं होगी, मैं क्या करूं, एनवायरनमेंट कैसा है, क्रॉप की क्वालिटी कैसी है, सीड्स की क्वालिटी कैसी है. सो ऑल दीज थिंग्स. सो लेट मी टेक वन एग्जांपल where I am going to talk about groundwater quality. I've taken this particular case study from Telangana. Their open data portal. You can also get this particular thing data online available on kaggle.com. I'll share all the resources with you after the session. So water is essential for all the crops and livestock. When you consume groundwater, you need to ensure that quality is good. Otherwise, it will affect crop and livestock. Now, the problem statement. Slowly and slowly, I'm trying to implement the AI project lifecycle in steps, right? So, problem statement. I need to know whether the groundwater of a particular area is usable or not, whether the water can be put to appropriate use, or can a farmer grow specific crop which can tolerate this particular quality of water. So this is a problem statement. I hope you can correlate better because you are the experts in this particular field. So data set, what data I need to capture? I was talking about the importance of data. So I will go to a district, mandal, village, then I'll capture the latitude and longitude of that particular village, go for chemical analysis of the water, various chemical parameters, hardness, dissolved solids, then RSC, SAR, etc. So these are the things I need to capture. And then what I need to predict, what are the targets, target variable. So first thing is I need to classify whether this water is good for irrigation or not. So these are the target variables. C1S1, C2S1, C3S1, C3S2, and all that. So high salinity, low sodium, high sodium, low salinity, high sodium, various combinations, permutation and combination. And whatsoever written on the right hand side, good for irrigation, requires good drainage, requires special soil management, not suitable for irrigation and all that. So you are the people, you are the domain experts who will vouch these things. It may vary from state to state, it may vary from farm to farm, it may vary from village to village, but yes, so that is how you are slowly and slowly progressing towards implementing. Whether I can tell any farmer that yes, you give me your water and I'll tell you what can be done over here. That is one particular point. Second, PSUSMR, permissible standards, undesirable substances, and maximum residue. So these are two things. One is classification, target variable I'm talking about. One is classification and one is classification.1. You can give any name. It is entirely up to you. So I have given classification and classification 1. And then when you talk about, so this is primarily based upon Central Pollution Control Board in India, CPCB. So they have defined their own parameters, limits, etc. That yes, this is permissible, this is undesirable, this is maximum residue and all that. So I need to tell that yes, this water is good for crop, good for irrigation, or this water has permissible amount of components. So let us implement it very quickly. So I'm talking about a use case implementation using no code. Till now, you might have observed or you might have worked using Python, writing a code for this particular thing. I at Mystic Mind try to bring one particular concept of no code. You don't need to write any code. I'll show you today with a very small example, this example only, where you don't need to write a code, but you can implement a complete AI project. That is the beauty we at Mystic Mind are working on. Let me show you. So this is one data set. Sena sir, able to see the Excel sheet?
Yes, sir. Yes, sir.
Good. So this is where I'll quickly glance through the data. This is what I have got from Telangana open data portal. You can also get it, right? So district, mandal, village, then longitude, latitude, and season is primarily post monsoon, because water contamination happens during post monsoon generally. Generally. Then various parameters, various components. You are the experts to gauge the importance of each and every component, right? And then I do have, this is classification. This is what we talked about. And this is classification 1, where we talked about PS, USMS, right? So that is where this particular data has 374 data rows. So you get the data. So this is step number 2. First, we define the problem and then we start working on data. Third point. Now we need to start working on it. So there is one no-code platform by the name Rapid Miner. I'll share the details with you. So this is I have installed, because at this moment of time we are working on 30,000 feet. I'll give you a very brief demo so that you understand that yes, that is how things can move without writing even a single line of code, right? So I have imported, so import data option is there. So I have imported this particular data Excel sheet in my local. So groundwater quality 2018. So this is what my Excel sheet name is, right? So I have imported that particular data in my Rapid Miner interface. Let me do one thing. Let me start one new process. New process is, let me start with blank. Let me first drag and drop this particular data into my process sheet. I've just drag and drop. I have done this. So first thing first, this particular data is available with me. Let me connect the output of this data to the result. Just drag and drop. Very simple. Do not worry what I'm doing. Just try to see how important the output will be. So I'm running this. So this is a run button over here. I'm running it. So see, this is what I do have. We have seen this Excel sheet. So this is the Excel sheet I have got. Right? I can see the statistics. So this is available out of box that yes, this is the mean, median, mode, average, data point and all that. Visualization I can do. Various graphs are available, right? Various graphs are available. You can just play around with this and then go to design again. So this is what my data set is. This is the first step. I've taken that particular data set into my interface. Next step is I need to tell the no code platform that which are the target parameters. Target parameters means I need to set the role. So set role. So I have written over there set role. So there is one component available. The beauty of this particular platform is everything is available as component. You don't need to write anything. You just need to know that yes, this component is available. And you click over there, just connect this data set to set role. Click on that, edit list. Here I am doing very quickly, but when we'll do a complete workshop, I'll go very slowly. So I need to tell Rapid Miner that yes, this is a label and label is, let me say, classification 1. I can choose classification also, apply it. And now we took one example of pictures of dog and cat. And then we talked about that 1000 first picture. That will be the test picture. So here in this 364 rows, I need to divide this particular data set into two parts, like 70% training and 30% test. So let me say split data. So block is available. I just drag and drop. And this example, I need to connect over here. And then I need to connect on split data, edit. I need to tell the no code platform, that what amount of data should be taken as training data and what amount of data should be taken as test data. So let me add entry. So let me say 70% is training and 30% is test. Okay, so this is third step. Now I need to implement one algorithm. When you are working in Python, when Python tells you to code an algorithm, but here just see the operators. Various algorithms are available under the head of modeling. Modeling, I need to predict. Let me take one particular algorithm by the name decision tree. Just drag and drop decision tree. So this is done. Then I need to tell that yes, first data will be given to training. Just see training set, decision tree training set. So this is where training will happen. And then I need to apply this model. Apply model, again block is available. I just drag and drop. And then first particular part I am giving as model data, and second from the split, that 30% as given as UNL, unlabeled. When you click on this, so it will tell you that yes, this is unlabeled, right? And then when you apply this, you need to check the performance also. The performance block is available. You just drag and drop. Let me put over here so that it is visible. Just collect it over here. And my process is done. Just see how quickly I have modeled one algorithm with my data, with my problem statement, and now I need to run it out. Just again, run button is available. So let me run it out. Just see. Now observe the same data set which we saw few minutes back did not have these colors. This classification, and again this is prediction, and then confidence of PS, US, and MR. That is how things are moving. Now there is a performance vector where it is sharing that accuracy is 97.32%. That is where a lot of researchers, you might have seen that a lot of researchers are writing research papers very quickly. When it comes to AI in agriculture, they are using these tools, which are very, very quick, will give you a clear indication. Now I have taken one decision tree algorithm. You can take 5 more algorithms, right? 5 more algorithms, implement it, take that particular matrix, take a problem statement, and your research paper is ready. See how quickly, how beautiful it is, right? So this is where we are trying to engage non-CSE people, non-CSE students like agriculture, to work on AI projects without writing a code altogether. So this is one very, very important thing you need to see. So that is where example set, you see the statistics. So various parameters are there. You can analyze it. Various visualizations are available, right? So you just see. So these are the graphs which are available in our research papers, you know, and it doesn't take a minute altogether. You need to know that yes, these are the algorithms. You don't need to know the mathematics behind it. You need to know the process. You need to know the AI project life cycle. You need to pick the blocks and how you can implement it. I hope I'm making sense out of it. So very quickly, because this is a very small initial session altogether, so I wanted to give you various blocks. for exploration in coming days. So let me come back. So this is what we have implemented using no code platform. See, it did not take even 5 minutes for me to implement an AI project when I do have a good data, because data cleaning will be another exercise which will be done, because that's what I talked about, that when we were talking about these 10 blocks, each block will require a specific intervention. We did problem identification, we got the data, we got the algorithm, and we evaluated. These 4 steps we have done in last few minutes. So that is how we can implement it. So this was one. There are many. Simple farming is moving to smart farming. Lot of things are there. Then simple crop production is moving to intelligent crop planning and sowing. Lot of AI intervention is there. We are moving from manual agriculture to data driven agriculture. Lot of AI intervention is there. And then we are moving from man-made farming to technology driven precision farming. Lot of AI components are there. So I'm taking few examples, but there are 40 domains. 40 domains means 40 subjects of BSc agriculture, which you can take as a separate ocean altogether, drill down, take a thing. We are trying to make around 200 use cases out of those 40 subjects. So that is where we can say that this subject, yes, we do have 5 use cases. This is where I can suggest the researchers in this particular session to start exploring, because you take one subject, drill down to 5-10 problems, start implementing, get the data, start implementing using no code platform. And this no code platform is available. I'll tell you the complete process of getting it. So turning it 30,000 feet strategy into 300 feet roadmap. How to do that? This is important. This is important. Today we have talked about WWWH. Why, where, what, and how. WWWH of AI. That is what we are talking about. Why AI for agriculture? Is it good for my career prospects? We are going to talk about last point in next couple of minutes. Then we need to drill down to 10,000 feet. When we are talking about 10,000 feet, we need to work on this no code AI platform. Start exploring various things, start exploring various options, start doing data cleaning, start managing the algorithms which are available out of box. You just need to drag and drop, nothing more than that. Then you come to 1,000 feet. 1,000 feet means you need to implement those AI algorithms using no code AI platform. You don't need to write even a single line of code. Everything is available, drag and drop. Come to 100 feet, where you need to integrate various use cases. We are talking about 40 subjects and then multiply by 200 use cases and all that. Then come to 1 feet, where you need to optimize and tailor AI solution, where you will meet the industry, where you will monetize this particular thing altogether. That is how journey from 30,000 feet to 1 feet. Very, very critical. Very, very critical. Everybody should understand this. But yes, our education system is lacking in alignment, right? What industry requires, industry is moving very fast on AI, but our academic curriculum, you might have seen that we do have only one subject that is also elective, AI elective in the 5th Dean curriculum. And that particular subject talks about theoretical things altogether. You don't have to make it out that yes, you will not be industry ready by reading that subject. So you need to work hard, because we are fighting with an orthodox curriculum. Skill gaps are there. Curriculum must be industry ready. So currently we are following ICAR, and we cannot touch that particular prescribed curriculum. But yes, we can go an extra mile to get ourselves future ready. So this is where my suggestion would be. So jobs are very, very important, and most of the jobs are moving towards data analytics, machine learning, AI, and all that. So that is how we can move. So brief introduction. I'll tell you how also. Let me very quickly tell you how also. We are here to help you out. We are working on it. So we offer 24 weeks internship under student ready program. So you do have a component of ready program in 7th and 8th semester under skill development training, 24 weeks, where we can offer you 24 weeks internship on AI in agriculture. That is where we work on various use cases, various aspects. We make sure that you are working on agriculture with the help of artificial intelligence. So this is where we intermingle, integrate AI into agriculture. So it is virtual, work on no code, industry aligned student profiling is done, personalized internship is there, project plan is there, industry specific capstone projects are there. And then we ensure that the students who undergo this particular training get at least double the salary package which a common BSc agriculture student get. So that is one particular thing we go for. And when you build your competencies, so this is where you need to work on 4 quadrants. You need to be very good in statistics and mathematics. You need to know machine learning algorithms in a broad way. Broad way means you don't need to understand the mathematics behind it. You just need to know what decision tree is all about, what KNN is all about, what deep learning algorithm is all about. And then you need to know, you need to have a hands-on knowledge of no code AI platform. Domain knowledge, you are the experts. You are the agriculturist. So you know ins and outs of agriculture. And these 4 quadrants you need to work on so that you start demanding a good package in the industry. So this is very small thing I wanted to share with you today. I'm open to the questions now, sir.
So thank you so much, sir, for the presentation. It was really very insightful, and I hope all the participants are benefited by this. So we'll take few questions in the chat box. So we have a question that can you share the presentation? Yeah, so I'll take the presentation from sir and I'll share it in the WhatsApp group. So
I will
there's
do
another,
that.
yes, sir. So there's another question whether the Rapid Manner is a free AI interface or not.
Answer is yes. If you register with your university email ID, official email ID, it is free.
Okay, that's great. So the other next question is, um, if any in-service agriculture department government expert have an idea of startup with reference to AI and he doesn't have any computer experts or a team of experts, how he can complete his ideas into reality? To whom he should approach? So your
Great.
insights on this, sir. Yeah.
Good question. There are two answers, sir. There are two answers. First answer is definitely yes. There are a lot of computer science experts are available. You can take help from. So this is answer number one. But answer number two is build your own competencies. Agriculture is your domain area. You only need to know a few nitty-gritties of AI, and that is where we need you to work on, right? So you don't need to look for any help outside. You need to build your own competencies. This is the second answer, sir.
Yes, sir. Uh, so is today's workshop lecture will be available on YouTube or any other source?
I'll try to make it available, sir.
Okay, okay, fine. So official email means any specific domain like .edu. Yeah, yeah, yeah. It
Yes,
means the
yes,
same.
yes,
Yes.
yes.
Yeah. So you can't log in
Like
with
like
your
at
Gmail.
at bau.edu.in.
Right, right, right. Yes, sir.
Because if you go for Gmail and .com, they will
Yeah,
not give you free.
absolutely.
If
Yeah.
you go for .edu.in, they will give you free.
Yes, yes. So you need an official email ID.
Yes, sir.
Then it will work. Yeah.
Yes, sir.
Thank you. So from where we can get the complete course? So you can get in touch with sir. I'll also share his email ID. So in that case, you can contact him also.
Yes,
So if you have,
I'll share one complete brochure with you. You can circulate among them
sure, sir,
and share my email ID also. If
sure, sir.
anybody is interested, I can take it forward, sir.
Right, sir, right, sir. So so if you have any questions, you can unmute yourself and ask. You can take one question. If you have any question, you can unmute yourself and ask.
Please.
Otherwise, we have covered all the questions in the chat box. So there is also a feedback link in the chat box. So all of you are requested to fill that feedback form. And the second thing that I would like to announce is about the certificates. So you'll be getting all those who will be submit this feedback form, they'll be getting an email from us. And using the instructions on that email, you can download your certificates yourself. So it will be e-certificates. You can download those certificates, that certificate yourself, participation certificate for this workshop. So I hope that I think that there are no more questions. So session was really very insightful, sir, and I also got to learn a lot about rapid miner and all. So Tribhuvan, do you have any question? You can please ask.
Is I feel obliged to address this particular August gathering of a very famous agriculture university in India. So I know BAU has a particular place in the agriculture list of India. And I look forward to more engagements like this. And I'll be more than happy to assist or support any uh, researcher or any professor or any student if they want to work on AI.
Great,
Most
sir.
welcome.
Great. Yes, sir. So thank you so much, sir. On behalf of the university and on behalf of Center of Excellence in Teaching and Learning, I would like to thank you so much for your time today. And you were really very prompt in replying to us. So thank you so much, sir, once again. And I
Great.
hope that we will meet again in
And
the near
and can
future.
convey my best regards to your Honorable Vice Chancellor, sir,
Absolutely. Yes, sir.
your head of the department, sir, principal, sir, and all that. And
Yes, sir.
I'll be more than happy to assist in any way they want to. Thank you.
Yes, sir. Sure, sir. Thank you, sir. Thank you so much.
Thank you. Thank
We
you.
can leave the session now.
Yeah, you can leave this, sir.
Yes, thank you.